शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्कर प्रकृतिभिर्देवै सदा वन्दिता सा मां पातु सरस्वती सरस्वती भगवती माता सरस्वती शारदा माता सरस्वती शारदा हे माता सरस्वती शारदा विद्यादानी दयानी दुःखहरिणी जगत जननी ज्वालामुखी माता सरस्वती शारदा हे माता सरस्वती शारदा विद्यादानी दयानी दुःखहरिणी जगत जननी ज्वालामुखी माता सरस्वती शारदा हे माता सरस्वती शारदा Welcome everyone, Dr. Mukherjee, Dr. Lin, Dr. Ghate not yet entered. So first I like to introduce our first speaker. Hello Debbie. Hello Debbie.
Hello.
Hi, how are you?
I'm good. How are you doing?
I'm doing fine. I like to introduce you first,
Sure.
and then you can take over.
That sounds good.
After a long time, huh?
Yes, absolutely.
I don't want to take too much time. She's exponentially talented doctor as well as engineer. She did her, at present she is the attendee in the Massachusetts General Hospital. Dr. Debbie Lin did her MD from Harvard School of Medicine. And she did her Master of Engineering in Cardiopulmonary Focus with Dean's Fellowship from Boston University. She is having long CV with exponential credential, and she did her, at present she is the instructor or Harvard Medical School. She is having laboratory, MIT D laboratory, and she is pioneer in instrumentation also, and she is having number of peers review publication. 2020 COVID drugs live in systemic review from her present workplace, that is Massachusetts General Hospital. Her collaborator Dr. Benjamin and other members of COVID drugs living systemic review group, role of automation and in vitro studies lead. 2011 Sarji Box collaborated with JB Dr. Heather and spreading collaboration among MIT D Lab, MGH Division of Trauma, Swiss Essential Track, Health Novartis, Medicine Scan Frontiers, and US Department of Defense. And she's having many scholarship and a very prestigious scholarship from Harvard School also. She got Dean Scholarship, notable policy making contribution. She did 2019 Safe Surgery 2020 at UN General Assembly and present on non-communicable disease burden. 2019 TDX London exhibit on humanitarian care, and 2000s many other very prominent contributions she has done in a policy making also. 2016 Wall Street Journal interviewed on review on healthcare and selected, here I am mentioning some her selective service activity. At present, she is in Mass General Birmingham COVID Innovation Center since 2020, with focusing on helping to optimize, rapidly bringing to beside a variety of technology in isolation, personal protective equipment, and fully body protection, etc. And she is the reviewer, editorial reviewer for a very prominent journal, PLOS Medical Devices, IEE Global Health Technology, Medical Innovation, Ecosystem, Public Health, advisor and co-founder of Robert Murphy Physician Innovation Investigation Path, and selected recognition. 2020, she was the finalist MIT Solve Global Health Security. 2019 Innovator Award from Wellcome Trust. 2018 Create the Future from NASA. And 2016, in between she had many other recognition from US Army, Mass Challenges, Boston, Brown Medicine Clerkship, Harvard Medical School, President's Challenges, Harvard University, Social Impact with her groundbreaking work, Sarji Box. And 2016 Professional Fellowship, American Association University Medicine, Women, Medicine and Engineering, and she is got nominated by Wellcome Trust, and she is working with WHO. She is having exponential career, but luckily I found her when she was very good researcher in a class 10th grade in UCLA. She came to my lab as a for a project student. Morning shows the day. That time I know she is going to rise more. And now this is the documentation, and we are very fortunate to have Dr. Debbie Lean, because she is the MD from Harvard School as well as Master of Engineers. Now, I would request her to go ahead with her lecture. Welcome, Debbie.
Thank you so much, Eliza. And I cannot understate the impact of the mentorship that you've had on me over the years. And it's no surprise to me at all that you've been able to assume leadership of this prestigious institution and to be able to hopefully get to share that mentorship with many more other impressionable young minds as well. So I was hoping to get to share a little bit about a topic that I hope is at least a little bit familiar to many people. Are you able to see my slides?
Yes, I can see your slides.
Perfect. And I think that at least a little bit of this topic will be familiar to everybody, but I'm hoping that
you have 40 minutes time. You can go ahead with that. I know you are very busy. 40 minutes, 40 to 45 minutes you can take. No problem.
Thank you so much. I really appreciate it. And so the topic that is quite near and dear to my heart is biodesign, which is your user-driven and user-centered innovation. And I had so I am very, very honored to have the opportunity to participate in this inaugural lecture series. And the objectives for today are to be able to focus on, if in effect, have systematic ways to do things, have very systematic ways to evaluate the needs across the different aspects of innovation opportunity that folks at MEAT might be able to see in technology and therapeutics and laboratory practices and other practices and systems overall, to be able to understand and to deploy frameworks for implementation of iterative solution finding and testing, and also have an idea of some of the major pitfalls that can happen at each step of the innovation process and some ways to preempt them. Of course, each of these can be the work of a lifetime, so I won't pretend to cover everything, but I would love to at least be able to start the conversation. And I was getting to learn more about MEAT. Of course, MEAT is a regionally well-known and indeed globally prestigious institution, but it was interesting for me to go back a little bit and think about what are institutional priorities. And the vision and mission is certainly one that I found unique in looking at a lot of vision statements, mission statements over the year. And I think the thing that really jumped out at me is its mandate to mold young minds into skilled, competent, and social responsible citizens who will lead the building of a powerful nation. And that brings us to the question, right? What does it mean to build a powerful nation? What does that demand? What does it mean to build a powerful workforce? What does it mean for each of the leaders that are coming out of MEAT who are going into all the aspects of industry and government and the armed forces and beyond, in academia, and who will become leaders in these fields? What does it actually mean to have something that to be able to build things that's going to be sustainable and successful? There is a critical importance of discovery, of course, as well as of innovation, trying to build things, to make some use of that discovery and to defend the gains that are made over time. There is often back and forth of innovative and conservative forces, both of which are important to ensure that that changes are able to are able to be grounded in reality. Troubleshooting, nothing is ever always perfect and smooth. It looks, when you have an icon like this, it looks like you just plop a roof on a house, but in reality, there's the foundation building. There's what happens when your crane is just a little bit off kilter and your roof is just a few angles off. And also, we all know this. I mean, you don't get to meet it without realizing this, but hard work is tremendously important in this whole process. And of course, collaboration. When you're trying to tackle big ambitious projects, you can't do it alone. You definitely have to do it with other people who are like-minded and share your mission. So this is perhaps one of the best known graphs across the innovation field. This is it's ripped from a textbook, and it's the classic biodesign framework, which comes out of the Stanford Biodesign Fellowship Program. Now you'll notice that Stanford is in California and I'm based out of Boston. So this is recognizing the global impact that this framework has had. If we have the opportunity, we can always talk later on about some of the extensions, the optimizations and things of that sort, and understanding over the years of biodesign. But the core idea still holds that if you're trying to have innovation of any kind, whether it's a system innovation, a biotechnological innovation, or a medical device or other, such concrete innovations, that it really requires three separate steps that are very closely intertwined and is not linear, but keeps progressing and looping back on itself iteratively. So there's the step of identification, inventing, and implementing. And we'll get to map into each of these separately. So, I think the first time that I saw this, I was kind of skeptical, because there was the question on my mind of, well, of course you have to figure out what you're solving and then solve it and then implement the solving. So how is that groundbreaking? Why are people so finding this to be such an important issue? And and this is also questioning biodesign as opposed to what. People have been doing innovation, of course, for more than about 30 years or so that this paradigm has been around. So what have people been doing? And I think it's important to first map out what are the sort of distinctive aspects, not all of which I would say are unique, but the combination of which defines biodesign. The first, it's the fact that it's very needs oriented. I think that prior to this, and indeed even across a lot of innovative efforts even now, there's a real big desire to say, all right, I have spent my life working on X technology. I've become the person to do everything on 3D printing optimization for metalworking or something like that. And say, all right, so I know everything possible about 3D printing for metalworking. So now what can I apply it to? Which is an honorable way to innovate too, like having the ability, being able to develop capabilities that are widely valuable, or for that matter, genetic engineering to CRISPR, things that are valuable, and then being able to say what are the problems I can solve with it. But biodesign is focused first on needs finding and letting the needs define your usage. It's also acknowledging that it's incredibly interdisciplinary, because it is extremely rare and should not be regarded as a norm or expectation that the same person who does the business planning, for example, at step 6, is also going to be the person who's doing the concept generation, for example. So it really mandates that folks from business, from the technical, the scientific and technical fields, and everyone else are able to come together. It's also acknowledging that it's an iterative process. It's based on the idea that there are many possible problems or many ways you can slice and dice an issue that needs to be solved, and many possible problems, as well as many possible solutions for which there needs to be rational ways that you can screen and to optimize from within those. So let's go through these step by step. I think it bears getting down into some of the nuts and bolts. So the first step you'll remember is a needs finding within the identification sector. And this is incredibly important. And I cannot tell you how many times over the years, whether I myself or in advising others or working with other entities, the effort to do a needs finding is absolutely critical, because doing that right can set you up for success, and doing that wrong will wind up being incredibly costly down the line. And this is where you have to make the distinction between needs finding versus you have a solution and you're just trying to say this solution is needed. There's also, again, a role for that, but that's not within the paradigm of biodesign. So the distinction, as an example, as you can see from this cartoon, is if, say, you fell and you scuffed your knee and you're trying to figure out how to stop the bleeding. It's one thing to say, I need a bandage, which there's a role for that, right? Sometimes you just need a bandage. But sometimes you really need to be stepping back and say, at the step of need finding, I need some way to stop my knee from bleeding because it's bleeding all over the place and getting all over my clothes. Because that engenders a different opportunities down the line. If you're saying you need a bandage, you literally find a bandage. If you're needing a way to stop your knee from bleeding, some people find pressure bandages. Some people find that you could use, say, super glue or Dermabond or other technologies that will succeed in stopping your knee from bleeding. And on the maker side, that also has implications for, instead of looking for a specific drill bit, you'll say, I need to find a way to make a hole. There are numerous ways that people can potentially make holes. And so trying to frame it in the more abstract and higher level needs helps you to make sure that you're being inclusive of possible solutions. There's a lot of different ways that people define pain points. And I realize that pain points is a not uncontroversial way to call it, because sometimes it's also you're trying to find optimization opportunities, right? Or you're just plain finding opportunities. For some people, for people who work in, say, social media, they might see this as, I am designing an app that brings happiness. They may or may not see this as finding pain points, but I would tend to say that the most valuable and easiest to implement things, by which I mean you can most easily find stakeholders who are willing to embrace your idea, tend to tackle one or more of maybe 4 different topics, the 4 M's, if you were. Money, something that is hemorrhaging an institution or a stakeholder money or other resources. Misery, which is causing a significant literal pain, morbidity, or other things that actually cause a lot of consternation. Mortality, especially folks who work within the biotech sector or medical device sector, realize that if you're able to save lives, then it's an incredibly powerful thing to be able to prove. And of course, the last is man and woman power. To be able to save labor, to save time, is absolutely critical in many institutions. That also goes closely hand in hand with the mandate in many entities to be able to save money. If you're able to find if you're looking to solve a pain point that is costing money, misery, mortality, or manpower, then chances are you've got something that will be of value to an institution. And so your opportunity is your unique value proposition, and it's a mix of what users need and what you can offer at the end of the day. And so when you're going into the identification process and you're trying to map out the needs, and you have a general idea of that a need exists somewhere in an institution, I'd say that one of the first things to figure out early on is who is involved and who is affected. And by which I mean, who are the stakeholders? To whom does it matter that you're able to solve this problem? And this chart or the stakeholder map I borrow shamelessly from my colleague, Dr. Richard Boyer, who has leapt to international stardom for running the COVID challenge to develop a low-cost solutions for the ventilator challenge in the setting of COVID. And so he was explaining to folks how there's a lot of people for whom being able to achieve a rapidly deployable, affordable solution in ventilator technology is important, and there's external stakeholders galore, as you can absolutely imagine. All the people for whom were whether NGOs or hospitals or health ministries or defense sectors or any number of entities for whom this is incredibly valuable. But even internally, just as a small snapshot, you have the healthcare professionals and the patients for whom this directly affects, of course. I think everyone thinks about these on some level. But within these, getting very, very granular, who's the acquisition committee? Oftentimes we find in biotech and healthcare that the people who are going to pay for a solution, use a solution, and be affected by a solution actually three different separate entities. The government is, of course, going to be part and parcel of many innovations within our sector. Manufacturers, or the people who are going to actually bring this to bear, as well as the payers. This is, and I realize that to a certain extent, this is a very US-based slide because of the way that our healthcare system is unique in a lot of ways, in the way that we set up our insurance system. But nonetheless, somebody pays for care, somebody pays for healthcare innovations, and it's important to account for those as well. And the other thing to be really cognizant of is, by when do we need to tackle this challenge? I'll give you an example. So I had been tapped to help to lead a innovation between Brigham and Women's Hospital, which is one of the other Harvard hospitals besides my main clinical institution, as in collaboration with MIT. And the mandate for us was trying to figure out how to make left ventricular assist devices, by which I mean heart pumps, more forgettable for patients. And in particular, one of the things that makes it incredibly high morbidity as well as high mortality is the fact that you have a pump that plugs directly into the heart and has to have a silicone cable with wires inside, running all the way out to a device that you wear, your battery that you wear on your hip for as long as you're using the device. And so this system has to have, since it goes from the heart to the outside, obviously has an exit point. And so this exit point is very prone to infection, is very prone to getting irritated, and also just kind of painful. Just imagine having a thing about the thickness of my little finger going, or perhaps a little thicker, going in and out of your heart for the rest of the time that you're using this device. And so when I got approached about this, it was very illustrative for me to learn about by when do we need to tackle this challenge, because there's an infinite number of ways you can slice and dice this problem. When you're having something as broad as making it forgettable, adjectives are very broad. But when we got down to it, the sort of consideration was, you need to tackle this fairly soon, because the entity for whom we're working on collaborating in industry is looking as well to try to bring online a novel set of technology that would hopefully help to make this inherently a lot more straightforward to use by eliminating the driveline aspect of it. So there will still be morbidity, but it won't be coming from the driveline. But until that technology comes online in the next 5 to 10 years, we need to have something to bridge. So solving it, I think that many people within the biotechnology sector and others in MIT will sympathize. If we're solving something that has to be deployed in the market within 5 to 10 years, that's extremely different from solving something that you can get onto the market and get to patients within 20 years or 50 years, because we have to, I think a lot of technology involves massive outlays of time and capital. And so that was really valuable for us to figure out. Now, where are the locations, and where can I learn more and get more resources? Chances are, if you're tackling this, you might be, the folks at MET and beyond are likely to be innovators in different stages. You might be the end user who identifies this thing in the lab does not work well and I want it to work well. You might be the one to realize, I heard my friend saying or collaborator saying that this is an issue that they're encountering within the health ministry. And I think that I have a technology that can probably help with it. You might also find that you're plugging in different places, but it's trying to figure out exactly where is the scope of the places that can use this technology and where can I learn more. And I bring up again, your unique value proposition, because I think this is an incredibly critical thing. Figure out, why do I want to tackle this specific problem as opposed to all the other problems that you can be tackling? It's not that you would necessarily only be able to tackle one problem at a time. I've definitely gotten to have the privilege to get to work across operational sectors within the hospital and local health system, as well as technological things, as well as career development things for young innovators. But the reality is, things take time. You don't want to be doing things in a partial fashion. You definitely don't want to become known as a person who takes on a lot of things and doesn't deliver on any of them, right? You want to actually make sure you're doing things that you're able and willing and able to invest the time in succeeding. And so it's really important early on to figure out, why do I want to tackle this problem, as well as the obvious things of why do your stakeholders care about tackling this problem. And so that's where the user's need and what you have on offer is going to be incredibly important to find that overlap. And then this is where you get really down into the nitty-gritty of things. I think I saw a hand raised. Shanti? Shanti?
Hello. Hello.
Hi.
Hi. You go ahead. Later, you can answer in a chat box. Okay?
That sounds good.
Uh-huh.
And so I think that we have to get really specific about mapping out a problem's boundaries and conditions as much as possible. And over time, I've gotten to develop a tremendous horror of adjectives in particular, because it can, it's one thing at the very early stage to say, I would love to have a solution that is small and portable and easy to use and all sorts of nice adjectives. I mean, frankly, if you can't find a set of adjectives for your needs problem that are uncontroversial, then that gets kind of, that can set off some red flags on your side of, maybe it's a little hard to get consensus about this need at all. But even after you figure out the set of adjectives that are mapping it out, I want this to be small, I want this to be efficient, I need this to be cost effective. You have to actually get into the nitty-gritty of exactly what that means, because otherwise you're going to be stuck in an infinite optimization cycle. What does it mean to be small? It means one thing for something to be small within, say, a surgical device that does X can be very different from something that is small for a hospital that is trying to reduce, say, the footprint of their electrical grid, right? So it's really important to get as many details, dimensions, numbers as you possibly can to map out a problem's boundaries and conditions. My colleague, Dr. Boyer, when he was running the COVID challenge, really got down to nitty-gritties of, you have to have a system that you can solve it however you want, but your solution is gonna have to figure out, how do you deliver X amount of airflow in liters per minute? How can you deliver this amount of oxygen enrichment at, within a certain time frame? How can you guarantee that you're going to have this specific pressure curve that's going to be delivered into a patient's lungs at a very predictable rate over time? How long do you know that this is going to be able to work for consistently on, with or without battery charge? And so these are all, and how do you know that this is easy to use? What's your paradigm in terms of fastness of training or things of that sort? So it's really important to map things out early on. And this also helps you to figure out what is already out there to address this problem. Because when you think about this more strategically, you can often find, there are ways I can address this problem that solve 1, 2, or 3 things within these conditions, but this is where the actual need gap actually is. So I think that if you're trying to tackle a need and you find that there's absolutely nothing out there to address this problem whatsoever, that gets a little suspicious, because in the vast majority of circumstances, if it's an important problem, someone else should already be tackling it on some level. It's might not be the way you're thinking of it, but it should at least someone is trying to address it, you know? So as an example, when uh, when I started working on one of my endeavors, which is the surgery box for safe surgery. It's true that at the time that I started working on this 2011, there wasn't a huge number of people working within the safe surgery sector, but this was not a known need. It was only 4 or 5 years later that the data came out that more people die from surgically addressable conditions than TB, malaria, and HIV/AIDS combined. But even before then, it was already known within the sector to be a problem that you can't have safe surgery, and there's extraordinarily high infection rates if you have unsafe surgery. So that part was already known. So who was already trying to solve this problem? So there are people trying to bring operating rooms in trailers and tents. There are people who, in the absence of operating rooms, are trying to find ways that they're disinfecting locally by spraying disinfectants into the air. There's people who are using lights and disinfecting lights, who are trying to use air blowers and things of that sort to try to approximate sterility in safe surgical settings. So there's already things out there to try to address the problem. And so trying to figure out exactly within your understanding of the problem where there's an existing gap. In another example, I remember that there was, when I was in medical school, somebody was bringing up in a lecture, one of my professors are bringing up, it would be so amazing if there were some way that you could have a reversible closure system in surgery. You operate on somebody and you have a reason to think you might need to reoperate for various reasons. Repeat closure, expected high infection risk, things that, or second stage operation. You want to just reversibly close the wound at the end of the procedure and be able to go back in later. As it turns out, there is already something out there, which is a surgical zipper that you install onto the wounds, and you can zip on and off, and then at the end of the procedure, or when you're sure that you're done with the procedures and you can actually close up the wound with sutures or staples, that this already exists out there. So, this needs finding wasn't necessarily having to solve something or get something. It's literally to figure out who's actually, what is actually out there already. And so he was very happy when I told him that that already existed. So I believe he's actually implementing that and using that at Children's Hospital. And I would say, at the end of it, hopefully you're able to find one single need that you're trying to address. And I'm saying, I put this Pew table, or this weighted matrix table here, because you'll probably find that there's a lot of different ways I can slice and dice a problem, right? So you want to figure out what is the specific need or sub-need within this to try to address. Remember, if you're mapping out the conditions properly, you're probably realizing, by the time that you're trying to solve one problem and you have to get into the nitty-gritty, such as you're trying to find a more efficient way to run Western blots, you want to make sure that you're able to actually address these. You'll have to be able to address it very specifically, and so you don't want to be overextending yourself, right? It's one thing to say you want to find a way that to speed up the process by which you can run your Western blots. It's another thing to say you want to speed up the way you can run Western blots and also ELISAs and also PCRs. And also, you know, by the time you're solving one problem, you really gotta really focus on it. And so at every single stage, even now, you know, Surgibox is a multi-million-dollar company, and even now we still, when we are trying to tackle different needs that come up or potential solutions, we still often will go back to the brass tacks and say, I want to set up criteria by which I am looking at this option as well as the different alternative things that we're trying to solve to make sure we're tackling the thing that is of highest priority to us. Whether it's stakeholder need, whether it's market need, or or market sector, whether it's time or expeditiousness, whatever it is, just mapping out the criteria and being honest about it and being really transparent to yourself. Why am I trying to address this? Why is it of maximal need? And so we get to the fun stage, you know, now that you've identified the need and what you're trying to solve, you're trying to figure out how you're actually going to solve it. And this is really, really fun. You know, it's the ideas galore. You're trying to ideate. And this is where, you know, like making sure you're being solution agnostic at the very beginning is relatively important, because even if you're the expert in some given technology, you want to think, is this technology a good match, as well as are there different ways I can apply this technology or modifications that's going to make it valuable, et cetera, et cetera. And so this is where having formal systems um, like ideation meetings, or alternatively things like hackathons, can be incredibly helpful. Having a judgment-free zone in which you're forced to provide multiple ideas to try to tackle the need. And I would say this is comprehensive as possible. You're not trying to map out every bit of the boundaries conditions so far, but you're trying to really say, this theoretically, if you're having high rates of infection from urinary tract infections within a given patient population, what are all the ways that you might be able to tackle this? You can load on antibiotics, you can try to reduce the instrumentation, you can try to use disinfection, you can use materials changes in the things that touch the patient's urinary tract, you can use probiotics, all those things, trying to be as open-minded as possible at this stage. Without thinking, is this something I personally can deliver, et cetera, because this is where you gotta also consider it as, I can try to leverage collaborations. This is an opportunity to work with different stakeholders, things of that sort. And then this is, you know, after you've got a huge pool, hopefully, of ideas, or at least some pool of ideas, it's good at this point to think about what are ones out of these ideas, what are ones that can actually be brought to bear to that will actually be able to address the problem's really specific needs. It may well be that you could say, all right, we know that some version of this solution already exists, and what are the ways that we can tackle this that, you know, builds on those, as well as can address this more specifically. And what is out there to address this problem. And out of those, you can hopefully get a little bit of filtering downwards. And then the next step is to try to filter it down a little more aggressively out of these things that at least pass a smell test for you of, yeah, this can potentially work to meet all these different conditions if implemented the right way. You want to start to try to screen the ideas a little more thoroughly. And this is where mock-ups are often very helpful. In the medical device sector and also an instrumentation sector, this can actually be incredibly critical. I'll give you an example, you know, like for some of our medical education things, when we're trying to train the next generation of doctors, we would often think, you know, this could be a cool idea. You know, it would be amazing if we started having every single student who came out of Harvard Medical School learning how to pass off a patient at transition times in this specific way. So there's a few different ways that we can, before we commit to having every single person who comes from Harvard Medical School learning it that specific way, it's good to maybe focus group it out, talk with other educators, talk with other faculty members, talk with the medical students and other folks on, you know, the people they're passing off to, like, is this going to be a reasonable thing to do? Trying it out, you'll often find there are things that are unexpected that make more or less sense. As it turns out, when I tried to do that when I was at Brown to try to train some trainees to do a pass-off system in a different way, we were finding that the way that we were doing it that way was actually made a lot more challenging by the way our electronic medical record system was set up. And so that was an unexpected hurdle that was useful to figure out in this while we were ideating and trying out relatively low cost mock-ups. I know a lot of things in biotechnology and medical, it can be hard to figure out ways that can mock things up that are not extremely costly. And to the extent that they're, at least in the US, there are government funds that are specifically dedicated for trying to do mini pilots and mini mock-ups, because it's really hard to do things in an agile fashion. But I've been very impressed over the years, like I've been very inspired by my colleagues including the biotechnology sector, finding ways to use low cost models or simulations to kind of approximate what they're expecting, whether it's to look at the way that a protein binds using existing technologies or images that are available in databases, or other modalities by which they're doing rapid screening. One of the things I was very impressed to see when I was investigating COVID therapeutics was that a lot of folks were trying to pre-screen old drugs, actually, because remembering you need to figure out a time frame that's going to be faster than getting a new drug through the regulatory process. They're screening old drugs against different models that had been validated before for coronaviruses of different kinds. And so that's inspirational. We know there's some pitfall, there's some pros and cons. No model's exactly perfect. We know that there's some things that screen through that were not so effective by the time you get to patients. And there's some things that probably got screened out realistically that might have also worked. So recognizing that you want probably one or more ways that you're mocking up or trying to reality test your different ideas that, so far remembering is, that it's passage a smell test to be able to hopefully to address the problem or the need that you've identified. And also you've figured out is actually tackles the problem in the particulars that you're going to need to. And so hopefully at this stage you have one or more opportunities that can fit all these bills. It's feasible. It tackles the things you needed to tackle. And it's just is hopefully vetted at some stage by the different stakeholders. And this is when you're trying to find different ways that you're trying to winnow down. And sometimes it's trying to get back to that table, right? Trying to use your huge table to say, all right, so we have these different solutions. So instead of, for the alternatives and the things on the columns, instead of having the different needs or problems, you're putting the different options for solution concepts. But same idea, you have the criteria and you're figuring out what's the weighting factor for each of these. And hopefully by these, you can find some final concept solution that you want to actually run with, or at least try to go through. And there's some big caveats, right? Like, don't under-invent. You don't want to be like, you know what, I think I'm going to try to tackle something big, but I'm only going to tackle a small piece of it, even though my stakeholders say that the minimal viable needs are going to be X, Y, and Z. I'm only going to tackle Y, and even though Y by itself is not a viable solution. But I think, honestly, the thing among technical people, the technocrats of the world, is people much more frequently tend to over-invent, I would say. You have people who say, I think I can do better than the conditions. I think I can keep innovating and get this thing to be half the size and, half the price. You want to keep inventing over and over. And that speaks volumes to the innovators, right? That you have people who want to be doing even better and better. But you also have to realize that the more times you iterate, the more cost you incur, as well as the time that you're spending into it. So you want to figure out how you're inventing at just the right amount so you're tackling the things your stakeholders care about and aren't going quite overboard with it. This is also important, and that's where scope creep is absolutely the enemy. If I could put anything in big highlights, that would be it. Trying to make sure you're avoiding scope creep. There's a reason he spent all that time on the identify stage, and that's because it's one thing to say, I am going to have a technology that is going to help to screen for X disease, but then this is something that I've seen at at almost every hackathon or maker event that I've been part of. I haven't. Oh, all right. So maybe the technology I want to use is using a a virtual tablet so people can be choosing and learning stuff from it or choosing stuff from it. And when you have these powerful technologies in hand, the scope creep is really, really common, and people start saying, if every single student has access to a tablet, why don't we also tag on this? Why don't we tag on that? Why don't we tag on these other things? Which is valuable, but I would have to say my experience is extraordinarily rare for people to be able to tackle all these simultaneously. It's better oftentimes to say, I figured out how to solve this need, actually solve this need. And after the need is solved and you've managed to deploy the tablet with your solution on it, with your app into to every user, for the users to decide, you know what, I also want this to solve some other pressing thing, potentially. That's at least one interpretation. And it's also realizing, I said, hopefully you'll wind up with one solution. Maybe you'll have more than one. And also you might have zero. You might realize, this problem as it stands is not one that I am aware of a good way to solve right now, or is I can think of ways to solve it, but that requires a nuclear power plant, the US military's backing, and some other things that I don't personally have right now. And that's entirely fine. That's entirely fine, and this happens, right? Like, so there's absolutely no dishonor to that. And I've definitely found, for example, in the setting of COVID, that this happened a great deal, and the ability to fail upward or to fail forward is incredibly valuable. I think every single person in the US, at least, was probably on some level trying to figure out how do we try to tackle the PP bottleneck. And so depending on the way that they're defining out the PP bottleneck and the problem statement, they might have things that are bigger or smaller to fail, to solve within this. And they might have it defined in such a way that, to be able to try to scale something or at the level that is demanded to solve this problem in this specific way, I would not be able to do that without having direct access to a factory immediately, things of that sort. And that's fine. It's good to know, and it's important to figure that out early on, as I would say. And you might also realize at some point while you're doing the concept screening that, all right, I'm realizing that this is something that for which there is already intellectual property in the invention process. There's already some massive regulatory hurdles. There are some reimbursement or business model issues, and those are fine. It's important to figure that out up front. I would say better to know at this stage rather than later on, and sometimes you don't know until later on, and that's fine. But the point I was trying to make, rather, of the folks with the PPE side, is it's been really interesting, though, to see that even among the people who tried and didn't solve a PP challenge as they were finding, a lot of those people subsequently go on to solve problems in related systems, whether it's vaccine delivery, tests, COVID testing needs, or other issues within with medical implications later on as the next stage. So that's incredibly honorable as well. And this is a stage at which I would really point out, again, trying to avoid scope creep, really, really defining out what's your minimum viable product. Hopefully you've done a little bit of a mock-up, you've done a little bit of piloting or something along those lines, or some crude works like or looks like model by which you're like, okay, so I have figured out that I want to have a solution that does this specifically, and this is what it has to do. There are some things that are nice to have if it's easy to also implement, but you'll often find that things that are nice to haves might be harder or sometimes, pleasantly surprisingly easier to implement than you're expecting. Like for example, for SurgeBox, we had this, you have to have a system by which you can have purge particles over patients so you're not having flies and dust setting on patients. That's kind of the minimum requirement. As it turns out, we said it would be nice if you're able to add laminar airflow to it. And so, and obviously it would be nice if you had 10 different other things like artificial intelligence, virtual reality, and augmented reality training capability, yada, yada, yada. But we realized, virtual reality is kind of hard to implement in a minimum viable product and not one that our stakeholders are demanding. By contrast, it's actually quite straightforward for us to implement a laminar airflow system that is consistent and cost effective. And so trying to suss out what's a minimum viable product that your consumers are demanding, as well as that you expect you can deliver upfront as well in the minimum, the shortest time possible. Everything's going to evolve when it actually reaches the end users. So just recognizing that and having the humility to face that, upfront. And so implementation is frankly a lot of the extension of the preliminary groundwork that you had already built when you were doing the invention process. And so I'd say there's a few key problems or questions that you're trying to solve on the implementation stage. How do you know that this innovation works? Works. You've figured out a little bit of the mock-ups, but this is a stage when you're really getting down to the finessing of your solution, whether it's the operational aspects, you've ironed out the kinks. How do you set up the R&D in a way that you're able to guarantee that this is working and not just, it works because I'm hoping it works, or it's kind of hopefully answering what you need to do. You really want it to actually work. How do you deliver this innovation very consistently? In medical devices, this implies you're setting your, what we call the sigmas, which is your tolerances for your construction or your manufacturing. In biotech, it's often time setting. How do you ensure that if you're doing a diagnostic, that this has the performance characteristic that you need, or the contaminant levels that are acceptable? How do you ensure that this will always get to the end users in the way that you're expecting it to, so that it's actually tackling the need that you identified up front? And this is more of how do you actually get it out there? What's your distribution channel? What's your partnerships and your strategic partnerships and your stakeholders that you need to engage to ensure that this actually gets out there? And this is, of course, everybody has some way that they implement the business model canvas. And I think it's important that you find one that works for you. I felt that it's important for me to use this one as illustration because my colleagues at EPFL Essential Tech, with whom I've partnered over the years, has used this to, considerable effect for finding ways to have more portable X-ray devices and Ebola tackling solutions and things of that sort. But the key thing is you want to make sure you're mapping it out. You have an idea in here all along the way of, I know what the value is. I know what I'm trying to solve, because remember, that was step one. And I know who my partners are going to be. Hopefully you've identified that early on as well. And I know exactly the value proposition, the intersection of me and what the user needs are. And this is where you're really mapping out, what are my distribution channels? What are the relationships I'm building? What are the numbers, the dollar signs? What do I need to actually fundraise if I need to fundraise to do this? Or what's the grants that I need to be able to bring to bear for success? And what does success look like? What are the numbers of people I'm reaching? Are you doing something for profits? In which case, what are the dollars of rupees that I'm trying to make sure we're able to achieve to make this a sustainable innovation? What are the benefits and the key performance measures? If it's that you're trying to, say, innovate a way for your institution to have more efficient PCR testing, how fast, what are the benchmark that you're trying to hit so that you can say, all right, I've succeeded? You don't want to have, things are getting better, and in which case, when you're trying to persuade people to adopt your innovation or to support your innovation, that can get really challenging to really say, I've been able to succeed, or I expect to be able to succeed, Or if you support me, I can prove that I will have succeeded, unless you actually have hard numbers to this. I will decrease your PCR time by 2 hours, for example, right? Like these are things, or your turnaround time by 2 hours. So those are the things that you want to really specifically be mapping out, at this stage. And hopefully in the course of implementation, you can see, are you succeeding at it? Or are you needing to go through more iterations to make sure that you're able to succeed? And this gets, and then we get back to the very beginning again. We talked about how by the end of the session, we'll hopefully have a framework in place to look at the needs, look at the solutions, looking at testing implementation. And so we talked about how this comes out of the biodesign framework, in which we're identifying, inventing, and implementing through a iterative process by which you have multiple ways that you're measuring out criteria in a systematic fashion. We've talked about how we've tried to talk a little bit about the different major pitfalls, the over-invention, the under-invention, the trying to solve too many things at a time, trying to hold yourself to excessively high standards, trying to make sure that you have support resources. We've talked a little bit about each of those, but I would argue that instead of having to memorize some big list and keep worrying about, are we actually tackling them, I've found over time that perhaps the easiest thing to do is to, and this is what the trophy with the eyes are for, keeping your eyes on the prize, remembering that your needs, the thing that had driven you, remember, why do I want to tackle this problem? And why do my stakeholders care about this problem? And, it's incredibly important for, trying to find your true north. For me, it's been patient care. What actually is going to help to what is actually going to help to ensure that I have a solution that can get to patients early on. When I was in engineering school and we were designing a new system to make ablation safer, we had all sorts of different, we can do this, we can do that, we can do it this some other way, and over the course of implementation, we had all sorts of technological questions as well as business questions that came up. And at the end of the day, the thing that always brought us back was, what does actually needed to ensure that patients stay safe during this procedure? And so that was our true north. That was very valuable to ensure that we stayed on track. And I hope that you'll have a similar sort of true north for yourself as well, whether it's ensuring that your patients do well, that your customers do well, that your institution is able to succeed and to thrive in this competitive ecosystem. And with that, I'm very happy to answer any questions.
Yes, now session is open for a question. You can attend the question through the chat box. Dr. Lin, it's an excellent talk, and it is, I think it's going to be very useful for our biotech and startup people. And I'm really appreciate you for your valuable contribution for our institute through this talk. And you share some time with us. You are an extremely busy person. I'm really very much thankful. After a long time, we got connected. So I hope you will run more things, more valuable things is waiting, which will come out from your mind and which can be utilized by the mankind. You have a good platform and your background also very strong. I really grateful for your time and talk. Thank you so much. If anyone having any question, please go through the chat box.
I see that Udit Narayan Sharma was asking, how can we commercialize a product and what are the chances of getting investor for biomedical devices? That's, I think, a really key question that I'm glad that you're thinking about early on. because having the ability to actually take your solution across the finish line is absolutely key. I think commercialization starts early on from, you know, the very beginning stage. When I say finding stakeholders, I think a non-trivial stakeholder we also have to think about is who's the investor, right? Who is the person or entity that is going to help to ensure that you're able to, one, have somewhere to sell a product to, and two, how can we ensure that that person there you have some way to support you, because nothing happens for I take that back. Oftentimes you can do a lot of things for free, especially in amazing academic settings like NIET, and you want to leverage that as much as you can, but you also want to realize that there's going to be a stage when you can't do things for free anymore. And the earlier you're able to move to getting professional things and professional resources, oftentimes the faster you can accelerate. Commercialization is a thorny one. I'm sure I can't answer to any, you know, any amount of adequacy within just a few minutes, but I think it's important that you develop the business plan as much as possible up front and figuring out who is this going to be valuable to. We're pretty fortunate that we live in an age in which we have a lot of accelerators as well as other resources to try to support innovators, especially in the age of COVID when everything has gone virtual. You could find a lot of these online, and you'll find that they're going to be they can be very useful to gain as networks. The chance of getting investment is incredibly heavily tied to your needs analysis and your needs finding up front. If you're trying to solve, because investment is always predicated on return on investment. You're trying to sell your idea as this is an idea, but ideas are a dime a dozen. You know, sorry, that's a US based phrase. It's a rupee for a million ideas, perhaps. And you're trying to ensure that you're saying this isn't just any random idea that someone's dreaming of while over some beers, which that might be it, but it's got someone or some ones who are legitimately working on that. You answer the who. There's a key time frame in which your return on investment is going to come back. That's the when. This is going to impact people in a sector that you hopefully care about, and that's the where and the what. And so that being able to answer those questions when you go to talk with anyone who might potentially be an investor is incredibly important. Hopefully that helps a little bit. I'm happy to talk more offline if you have more specifics about your device ideas or things or commercialization.
Thank you so much. Thank you so much for your time and explanation. We now our next speaker is Dr. Shutapa Mukherjee, Senior Scientific Officer, Chittaranjan National Cancer Institute. So I like to introduce Dr. Mukherjee. And Dr. Mukherjee have playing great role. I send many students to Chittaranjan National Cancer Institute for their training, and Dr. Mukherjee is their coordinator, and we got unconditional support for our MIT students from her. Many of our MIT students, after getting training, after getting BTech from our institute, they are appointed in a R&D. I remember few students, Harshal Kumar Mishra, Deepak Singh, Shikha Chaudhary, they were sometimes directly appointed in J Mitro. So if you go for student, if you go for a good training, job will after you. You need not to go after job. And I like to introduce Dr. Mukherjee. Dr. Shutapa Mukherjee is the Senior Scientific Officer in the Department of Environmental and Cancer Genesis Toxicology, Chittaranjan National Cancer Institute, Calcutta. Dr. Mukherjee had her undergrad, postgrad from Department of Zoology, Shantiniketan, Vishwabharati Central University. She did her PhD from same institute, environmental Department of environmental carcinogenesis and toxicology, and she had joined in CNCI 2009 as a senior scientific officer. Her research area includes involvement of different kinases in cancer apoptosis, associated signaling pathways in human cancer, with particular emphasis on overcoming drug resistance in cancer using natural phytochemicals. She has to credit more than 50 original publications in reputed international journal. She is a life member of many international cancer society and reviewer of some cancer journal of scientific report. So Dr. Mukherjee, now go ahead. Your time limit is 30 minutes. Okay. Thank you so much.
Okay. Am I audible?
Yes.
Thank you, Professor Chakraborty, for this nice introduction. And really, it's my privilege to be a part of this symposium or seminar webinar that is going on. And it's indeed a great effort from your side as well. So now my topic of my presentation is it visible? Slides are visible? Can you see the slides?
Madam, this is visible. Please go ahead.
Okay. Thank you. So the title of my presentation is Polycyclic Aromatic Hydrocarbons, Equally Important Contributors in Carcinogenesis of Uterine Cervix. So the question comes, why I am focusing on cervical cancer? So for which I want to take you to this slide, where you can see that cervical cancer is the fourth leading cause of morbidity and mortality among women, not only in India, but also globally, worldwide. And in India, due to poor socio-economic condition and lack of awareness, most of this disease, women suffers from this disease in advanced stage, means the disease is diagnosed in advanced stage. And which is accredited to recurrent relapse. So before going into the details of the cervical cancer, it is important to know the anatomy of the cervix, because until and unless we know the anatomy, we can't come to any conclusion or any side how the cervical carcinogenesis is going on. So cervix, you can see it is the very miniature part. It is the neck of the uterus. It demarcates uterus from vagina. This is the vagina and this is the uterus, and here lies the cervix. So cervix can be regionalized into endocervix and ectocervix. If we look into the cellular pattern, cellular composition, then it is clearly visible that cervix is made up of squamous epithelial cells and as well as columnar epithelial cells. And this is the squamo-columnar junction, which is the very, very vulnerable junction of the cervix. And to understand, because cervix is made up of stratified layers of epithelial cells, so the layers can be stratified. The different layers are just above the basement membrane. You can see basal cell layers, above which lies the parabasal layer. Then comes the intermediate cell layer, and in the upper strata of the cervical region lies the superficial layer. So basal cell layer, you can see nuclear content in the basal cell layer is very, very high. So for which nucleocytoplasmic ratio of basal layers are too high because they are the progenitors of mature cervical cells which lies in the upper strata. And gradually, if we go towards the upper strata, you can see gradual shrinkage and condensation of nucleus occurs because nuclei becomes smaller in size, and it is pycnotic nuclei, which is the mature cervical cells or cervical exfoliated cells. Since because of high nuclear content and because of progenitor-like functions or characteristic features, this site is the site for infection with HPV, the causative agent. So since human papilloma virus is the predominant cause, etiological factor for cervical cancer, because 97 to 98% means almost 100% of the cases are caused by human papilloma virus. So we have to know about what is human papilloma virus. It is a DNA virus of approx 8 kilobase pair size. Unlike coronavirus, which is, we all know that it is a RNA virus, but human papilloma virus is a DNA virus, and it is mostly transmitted by sexual contamination. This virus may also cause genital warts, and apart from cervical cancers, this human papilloma virus, you all of are aware that this type of virus may cause oral cancers and skin cancers as well. Epidemiologically, HPVs can be classified as high-risk HPVs and low-risk HPVs. Since we are discussing about cervical cancer, among high-risk HPVs, HPV 16, 18, and 33, these are mainly responsible for causative factor. These are the major etiological factors of cervical cancer. So it is important to understand the viral genome, HPV genome. Until and unless we know about the HPV genome, we can't understand the progression of the disease, how cervical carcinogenesis is occurring within the cervix. So HPV is a circular DNA. As you can see, it is a circular genome. It has several types of genes, early genes and late genes. So how HPV enters within these basal cells, as I discussed earlier, that basal cells, because of its high nuclear content and high progenitor-like properties, HPV enters within the basal layer and integrated within the basal cells of the cervical epithelium. Then the question comes, how this virus enters within the cervix? Entry of the virus occurs through cervical crevices, or you can say micro abrasions or micro lesions that occurred due to some injury or wound or any sort of injury. Some crevices may occur. Otherwise, cervical epithelial cells are very much highly compact. But when any sort of injury or lesion occurs, then virus enters within this epithelium through these crevices or micro lesions, and they enters within the basal cells through receptor mediated entry. And then the viral genome, DNA virus, the viral genome gets integrated within the host genome. Now, to sustain within the cervical microenvironment, the virus has to adapt itself. And for this adaptation, some viral genes come into play. These are E genes or early genes. And the proteins formed from these genes are E1, E2, E4, E5, E6, and E7. So what are the functions of these viral proteins? E1 protein interacts with E2 because E2 is very important gene, and to regulate the functional property of this E2 protein, E1 has to interact with E2, and E1 has some helicase and ATPase activities. What is the function of E2? E2 stringently regulates the activities of early genes E6 and E7, and by maintaining their copy number in the viral genome, because the virus has to integrated viral genome has to integrated within the host genome to form a episome for completion of its life cycle and for propagation as well. Until and unless the virus integrates with viral DNA integrates with the host DNA, it cannot propagate or it cannot complete its life cycle. So, there comes the functions of viral early genes or E genes. Now, what is the function of E4 protein? E4 interacts with keratin network of squamous epithelium and making a way for the viruses to reach the basal layer. E5 protein, it activates receptor tyrosine kinases, that is the main and major signaling cascades occurring during malignant transformation. And E6, E7, they are the predominant genes, and function of these proteins are E6 protein interacts with P53 protein and helps to proteasomal degradation of P53. P53 is a tumor suppressor protein. So degradation of tumor suppressor protein helps in accelerates the carcinogenic progression. Similarly, when E7 binds with RB, retinoblastoma protein, which is also a tumor suppressor protein, then binding of RB with E7 and thereafter phosphorylation of RB protein dissociates RB from E2F. E2F is a transcription factor and dissociates RB from E2F, and E2F becomes free, and E2F being transcription factor binds to the responsive element promoter region of the proliferating genes and thus helps in the proliferation of the viral genome and malignant transformation of the cell as well. So how this carcinogenic progression occurs upon entry of a human papilloma virus within cervix. So fast response, as you can see here, when viral genome integrates with the basal cells just lying above the basement membrane, the first response that occurs is altered interferon response, means an inflammatory response occurs so as to nullify the viral load, because that is the first response occurs within our body when any pathogen enters or any pathogenic insult occurs. The first response is activation of TGF beta or interference. Then if the viral load is too high, then the preliminary response cannot nullify the viral load, and sustained unremitted inflammation sometimes favors carcinogenesis process. That's why inflammation, you probably have come through the word that the inflammation is nothing but a double-edged sword. Because if inflammation is low, then it can combat, but inflammation if sustaining or it is unremitted, then it favors the carcinogenic progression. And prolonged sustained inflammation finally leads to angiogenesis or metastatic behavior of the cell, and then advanced stages, it gradually proceeds towards the advanced stages of the carcinoma, which is known as carcinoma in situ or metastatic cervical cancer stage. So if we look into the anatomy, because we have to understand how and where the cancer is being developed. So this is the cervical region, and in stage 1B, early stage 1B, cancer has been developed, but these stages are undetectable stages. No signs or symptoms can be observed externally. But when the cancer spreads towards the parametrium and almost towards uterus, then vaginal bleeding starts, which is the first sign and symptoms of any lesion or any abnormalities. During that stage, the question of therapy arises until and unless usually, that's why screening program is very, very important, cervical screening program, because until and unless the cancer stages 2B occurs, no signs or apparent symptoms can be observed. And from this stage onwards, when symptoms arises, then comes the question of therapy. So what is the main modality of or treatment therapy of cervical cancer? It is majorly surgery, followed by chemotherapy or radiotherapy. but most of the cases, clinicians practices chemoradiotherapy, concurrent chemoradiotherapy, where chemotherapy acts as a radiosensitizer. What are the drugs used in the treatment of cervical cancer? That is majorly platinum conjugated drugs, mostly cisplatin. Cisplatin is the drug of choice for the treatment of cervical cancer. So what are the factors? As I have mentioned earlier, that these early genes, E genes, they change the pandemonium of the cervix by following way. How? As I have mentioned, that they increase the pro-survival signaling. So consequence of this increased pro-survival signaling is that there is a drastic change in the metabolic profile of the cells. So there is a shift in the metabolic paradigm, which leads to increased drug metabolism. And increased drug metabolism means drug pharmacokinetics changes, and that leads to increased drug efflux. Drug efflux, and which results into reduced drug accumulation. And this reduced drug accumulation ultimately causes acute chemoresistance. And this is in my laboratory, this is our major focus, how and why acquired chemoresistance is being acquired in the progressive stages of cervical cancer. Even if you are using, clinician is giving chemotherapy or radiotherapy, the patient is not responding. Why? What are the major dilemma or major factors underlying this chemoresistance? That is the main interest going on in our laboratory. So, as I have mentioned you, that cisplatin, which is a cis dichlorodimine platinum moiety, apart from cisplatin, carboplatin, oxaliplatin, these drugs are also used, but predominantly cisplatin is the major choice for the treatment of cervical cancer. So in a nutshell, how cisplatin resistance occurs? Because of three factors. Number one, decreased drug influx. Number two, increased drug efflux. And number three, increased drug metabolism. All these factors cumulatively leads to reduced cisplatin accumulation within the cervical cells, for which the patient cannot respond even if the treatment procedure continues. So, to understand the underlying mechanism of cisplatin resistance, we have to develop one model. Until and unless we develop any model, we cannot understand the mechanisms, how this carcinogenic progression is going on. For which we have developed two models. One is in vitro model and another is in vivo. For today's presentation, we have selected this in vivo model, where we have used Swiss albino mice, 5 to 6 weeks old virgin female Swiss albino mice. So how mice were maintained? The animals were maintained in batches of 4 per cage, following 12 hours day and night cycle in the animal house. Food and water was provided ad libitum. And now, to simulate the changes, what are the changes going on in HPV infected cervical carcinogenesis, because human papilloma virus cannot be injected in mice, to simulate the process, what are the going on, to corroborate the pathway, we have painted the cervix of the mice with a carcinogen, which is polycyclic, belonging to the family of polycyclic aromatic hydrocarbons. So what are polycyclic aromatic hydrocarbons? They are, you can see, they are provided with multiple benzene rings. Polycyclic aromatic hydrocarbons, or PAHs, are major environmental pollutants. How these pollutants are coming to the environment? By several means, due to incomplete or complete combustion of fossil fuel, petroleum spillage, thermal plant, forest fire, volcanic eruptions, automobile exhaustion, all these emissions emits these hazardous hydrocarbon, polycyclic aromatic hydrocarbon. It is a major and potent environmental pollutant. So, but we have to keep in mind that these polycyclic aromatic hydrocarbons undergo biotransformation, rapid after entering within the cell, it undergoes rapid biotransformation to form an active metabolite, which ultimately binds with DNA and triggers carcinogenic process. What are the biotransformation? For example, benzpyrene, which is a very, very well known in cigarette smoking, in automobile exhaust, in power plant emissions, or benzpyrene is the major. Somebody has raised hand. Shall I continue? Sorry.
Yes, you continue, go ahead.
Okay. So benzpyrene, upon entering within the cell, the mitochondrial cytochrome P450, which is an enzyme belonging to electron transport chain system, this oxidizes benzpyrene into benz 7,5 epoxide. It is a representative carcinogen. I am just discussing about how biotransformation occurs. Then epoxide hydrolase, another enzyme that adds the hydroxyl groups, and again this cytochrome P450, the mitochondrial oxidase enzyme, this converts this diol to 9,10 epoxide. The carcinogen which I have used for our study, our team has used, is 3-methylcholanthrin, which is also a polycyclic aromatic hydrocarbon, and which mother compound of which is 7,12-DMBA, dimethyl benzanthracene, and this is the structure of 3-methylcholanthrin. So what we have done, firstly we kept all the mice, all the female mice in a cage away from male mice to bring about estrus synchrony in their estrus cycle, and male mice were kept away for avoiding any pheromonal influence, because estrogen, you know, estrogen is also a potent, it has some potent carcinogenic effect. So to rule out the effect of estrogen, we synchronized the estrus cycle of each and every mice and kept them away from male mice. Then we painted the cervix of the mice with carcinogen 3-methylcholanthrin solution chronically. And on an intermittent weekly basis, we checked the following parameters. We took out body weight of the mice. We performed pap smear test to ascertain whether any cytopathological changes are occurring. We studied leukocyte subpopulation, whether any leukocyte infiltration is occurring within the cervix or not. And obviously, we performed histology to understand the gradual progression of the carcinogenic process. And for genotoxicity and proliferation profile, we estimated ROS, RNase level. We estimated serum SGPT, SGOT, total antioxidant enzyme assay. To ensure DNA damage, we performed COMET assay. We estimated some cytokine levels, and immunohistochemically we observed what are the status of proliferative markers, and by Western blotting we checked some of the protein expressions. So if you look into the vaginal orifice of the mouse, then you can see that there is hardly any change in the vagina of control mice, whereas upon treatment with 3-methylcholanthrin, you can see a gradual swelling in the vaginal region, and on 30th week of treatment, severe lesion has been observed. Then we checked the body weight, and it is clear from this figure that upon treatment, there is a gradual loss of body weight up to 12 weeks, probably due to stress, and then rapidly body weight increases. That may be probable cause, might be that with increasing carcinogenic treatment, the tumor lump is also increasing, which might be giving some additive effect in the total body weight of the mice. So if you look into this slide, you can see with gradual increased treatment duration at 16th week, you can see that blood vessels have been developed. which is an indication of angiogenesis or metastatic behavior. And on 24th or week onwards, till 30th week, we found some lump-like structures, which is the tumor structure. Then we performed pap smear test. We collected cervical swab on a weekly basis and stained the slides with pap staining and observed under microscope. So it is clear from these figures that you can see in control cell, clear nuclei is visible. However, whereas upon 6th week of treatment, some keratinized cells are observed. And from 12th week onwards, you can see infiltration of leukocytes, which is an indication of inflammation. Probably some inflammation is occurring, which is increasing gradually. And if you can look into this slide, what are the changes going on? You can see that vacuolation, some vacuolation is occurring, binucleation, which are the indications of carcinogenic progression, and changed nuclear cytoplasmic ratio, which is an indication of proliferative signaling. So if we look into the leukocyte, there is a multitude of leukocyte subpopulation infiltrating within the cervix upon carcinogenic treatments. Firstly, up to 6th week, we found, our 12th week, we found high eosinophilic count, which was accompanied by greater neutrophil count and monocytes. All these things are indications that upon carcinogen treatment, some what should I say, some inflammation is occurring initially to nullify the carcinogenic effect. Inflammation is occurring because if you see the structure, morphological structure of neutrophils, you can see that here some undifferentiated neutrophils. Undifferentiated means not properly differentiated, means they are oozing out into the vaginal fluid to they wanted to go to the cervix to perform its function. Based on this cytopathological result, we checked histologic as well. So we dissected the cervix and performed histology. And this is the normal contour of the cervix, control mice. This is the normal cervix contour. And if you look into this slide where the mice has been insulted with carcinogen for 16 weeks, then you can see that the basal layer, which I have mentioned earlier, that basal cells, basal layer is invaginated towards the connective tissue. And if this invagination is up to 2/3, then it is known as CIN2. And in case it is more than 2/3, then it is known as CIN3 or severe dysplastic change or invasive stage. So in 30th week of treatment, you can see severe invagination towards connective tissue has occurred, and keratin pearl means highly keratinized cells have been observed. Highly keratinization means indication of rapid proliferation of epithelial cells. So this is the tumor mass. To ascertain whether this tumor mass is cervical squamous cell carcinoma or sarcoma, we have to rule out whether it is sarcoma or cervical squamous cell carcinoma. That's why we, for histological purpose, we take out the mass from different regions. We took out the cortex part, we took out the medullary part and the corticomedullary junction. And these are the histological features. Here, if you see that, as I have mentioned, that basal layer is invaginating towards the connective tissue or stroma layer. And here you can see in the corticomedullary part, the window screen will tell you that the cells, tumor cells are giant with more than one nuclei, multiple nuclei, and they are poorly differentiated anaplastic cells. These features are indicating that yes, aberrant carcinogenic progression is going on upon treatment of mice cervix with 3-methylcholanthrin. since we are using carcinogen, we felt curious to look into the histology of liver and spleen as well, because any change, any inflammation or change occurs in the localized region that may reflect some systemic stress. To look into the systemic stress, we perform liver histology, and this is the normal contour of the control liver of the control mice, whereas it is the liver of the mice treated with carcinogen, where you can see necrotic tissue, mononuclear infiltrates, means leukocyte infiltration is occurring within the liver, and deformed portal vein. Portal vein has been deformed. If you look into the spleen, this is the spleen of the normal mice, but here spleen is enlarged. Splenomegaly has been observed upon treatment with 30th weeks. And here, infiltrating eosinophils in the treated mice, germinal center. Germinal center is the site where B cell maturation occurs. So large numbers of B cells are growing in the germinal center. So germinal center has been increased, and infiltrating eosinophils are also visible in the slide. Based on these inflammatory indications, we next studied some biochemical parameters. So it is the control and treated. If you see, we measured SGPT, SGOT level. We found that SGPT, SGOT levels were increasing upon treatment, and which increases gradually with in a chronic way. And in nitric oxide, reactive oxygen species, these are the free radicals generated due to carcinogenic insult. They were also increasing. So moreover, we measured alkaline phosphatase and creatinine level, which were also found to be increased. These indicates that the carcinogen. Yes.
5 minutes
Yes?
more. 5 minutes more.
Yes, yes. I will be finished. Okay. And total antioxidant enzyme capacity was compromised upon treatment with 3-methylchloranthrene. All these indicates that the carcinogenic insult is not localized. It is some systemic stress is also occurring, and that is driving, and this inflammation is the driving force behind the carcinogenic progression. To ensure DNA damage, we performed COMET assay. And this is the COMET tail moment, where also we find that treatment increases the COMET tail moment, and leukocytic index, which is the ratio of number of leukocyte to total number of cells, that also increased. We measured proliferative markers, and that also increases upon treatment. And P53 initially expression, which is a tumor suppressor gene protein, increases, and later it decreases. P21 also decreases continually. So then we tried to look into whether proliferative markers are confined to only basal layers, or it is available in other layers of the cervical epithelium as well. So based on this table, you will find that these Chi67 and PCNA, which are the proliferating markers, they are scattered throughout the cervical epithelial layers, means basal, paramesal, intermediate layers, which is also indicating that cervical carcinogenic proliferations are going on. PCNA expression also reflected similar pattern. Now we checked the expression pattern of some inhibitor of apoptosis proteins, because inhibition of apoptosis favors the carcinogenic progression. Survivin, XIAP, and NF-kappa B, all these are pro-survival genes, and their expressions also increased during carcinogenic insult, and not only confined to basal cells, but also to other parts of the cervical stratum. So to overall findings can be summarized in a way that when we are treating the cells with carcinogen, some DNA damage is taking place, which generates free radical, ROS, RNS, and nitroxy radicals. And moreover, it increases IL-8 inflammatory cytokines. These are IL-6 increases, and IL-6 activates NF-kappa B, and IL-6 NF-kappa B axis also activates IL-8, and IL-8 is neutrophil activating factor that recruits neutrophil, and it increases COX-2 and proliferative markers. Similarly, in initially P21, RB, P53, which are tumor suppressor proteins, their expression increases, but upon continuous persistent DNA damage and inflammation, their expression decreases. So, to sum up, these damaged cellular biomolecules, because these free radicals damages lipids and proteins and of the biomembranes, and these damaged cellular biomolecules leads to loss in cellular architecture, and that is leading to hyperplasia, dysplasia, and finally neoplastic progression of the cervix. So this is our team, and this is she is Elizabeth, who did all entire work regarding development of in vivo model using 3-methylcholanthrin. Shalini is a new member of our team, and she is also working in the field of cervical cancer. And this is my alma mater where I am working, and a second campus has been developed at Rajarhat new campus. And thank you for your patience hearing. Thank you so much.
Thank you so much for your nice and very informative talk. And now session is open for question through chat box, because I'm so sorry we are running little late. Another speaker waiting from University of Southern California, Los Angeles, Dr. Nikhil Ghate, and he will speak on laboratory safety and what are the main precaution we should take. Dr. Ghate is a research associate in Nourish Comprehensive Cancer Research Center in the University of Southern California, Los Angeles. He is focused on targeting the epigenetics modifier leading to cancer to develop new anti-cancer therapy. He has completed his PhD in biochemistry from University of Calcutta from J.C. Bose Institute. His field now on cancer epigenetics, natural product research, drug development. He has published 30 papers in a reputed international peer-reviewed journal, and some are in PLOS and many other and high index journal. So Dr. Ghate, now you can speak. Hello.
Yeah, hi.
Hi.
Hello. I thank you for a nice introduction, Dr. Chakravarti, and that was a very nice talk by Dr. Mukherjee. I just have a question for Dr. Mukherjee. Is it okay if I ask now?
Yeah, if you, I would suggest you ask the questions through the chat box,
Okay.
and you start your talk.
Okay.
Because we are running little late.
Yeah.
All are requested use chat box to launch the question, and she will answer to you all.
Can you guys see the screen?
We can see.
Hello, hi. Good evening. Okay, although I am working in a cancer research lab, I'm not going to present the advances in a science or medicine. Okay, I am going to present on a laboratory biosafety, which I think is the most important and yet a very neglected guideline. Okay, most of you guys are the students who work in the laboratory of different setup. Some of you might be working in advanced laboratory in the future also. But remember, though the laboratories look fancy, but there are many hazardous stuff, including instruments, microbes, pathogens in a cultured cells, chemicals, etc., that you should be taken care of. In my lecture, I will be covering about the laboratory biosafety. I have divided my lecture into introduction, and then there is the most interesting part, which is the actual images, where I will show the laboratory images where what are the mistakes usually people do when they work in advanced laboratories. Okay, so that will lead to the practical guidelines, and so that you can directly relate with your lab working conditions. Okay, so the topic is laboratory biosafety and its importance during working in laboratory. Okay, so as I said, I have divided in two sections. So what are the safety considerations? So first section is a risk assessment, and the second is how we contend, which I think is the most important part. Okay, so firstly, risk assessment. So it is divided into four research groups. So research group one, research group two, research group three, and research group four. So research group ones contains agents that are not associated with the disease in healthy adult humans. In research group two, agents that are associated with human disease, which is rarely serious and for which preventive or therapeutic interventions are often available. Research group three, it's a most hazardous. It's a agents that are associated with serious or lethal human disease for which preventive or therapeutic interventions may be available, which is high individual risk but low community risk. So research group 4 is more about the community concern, which is agents that are likely to cause serious or lethal human disease for which preventive or therapeutic interventions are not usually available. That is a high individual risk as well as high community risk. So the risk assessment, under the risk assessment, so there are, it is divided into three parameters. So biological agent, then host and environment, and these three are related to each other. So in a, under biological agents, which stimulates and which are industry standards, and then agent identity and the vectors, acquisition and antibiotic resistant procedures and quantity of material. There are many like that. So, and the host is like who were working in the laboratory is the host. So that includes the management of the laboratory as well as the health professionals, and which also include how the what is the how the pathogens transfer, that is which is a mode of transmission, and what is the medical status. So if you are working in the laboratory, you should be getting vaccinated. If you are working in laboratory in where they work on hepatitis or like the viruses which are deadly and may cause a death. So in environment, okay, those are animals, means this is for the one who work with the animal. So then there are some regulation guidelines for that, and then social and political perceptions. So yeah, and the second one is a containment. Okay, as I'm saying, this is the most important part of, and this is a actual practical thing. So let's see. So under containment, there are three categories. So standard microbiological practices. Second is safety equipments, and then laboratory facilities. So this one is a so you can directly see. Okay, so in the right hand side, that is the sharp container. So whenever you are using any razor blade or any syringe or injections, use a sharp container. Okay, don't break it, don't bend it, don't put the cap again. Just put the open needle directly into the sharp container, but be careful. Okay, and if you can have a you can use alternative needle. Nowadays there are plastics needles available. You guys can use it. That is very good to use rather than a metal one. And please don't place the needle in the office waste container, because you can see on the left hand side that guy is picking up the office waste, and the syringe, the needle is protruding outside of the carry bag, and it's gonna hurt him. Next one, definitely use mechanical pipetting devices. Don't use pipettes where you gonna do mouth pipetting. Then whenever you finish the work, okay, wash your hands. So these three are the containments. How can we contain once you use? So see, this is the biological safety one facility plus, means above biological safety one. So there should be a decontamination method, which includes autoclave, and there is some offsite program, means autoclave either be present in the laboratory or they may be present in the central laboratory. And there should be a eye wash station present. You can see left hand side, that's a eye wash station. So whenever you have any aerosol or any drop of anything in your eyes, just go to the eye wash station and wash your eyes till 5 minutes. So I will just a little bit give an introduction about the biological safety cabinets, which I think everybody knows. So why biological safety cabinets are needed? It is needed for the production of product, personal as well as environment protection. So product means whatever you are working with, it should not get contaminated with the outside air, which includes bacteria or bacterial spores or viruses. So personal is the host which is working there, and the environment is definitely whatever the pathogens you are working in biological safety cabinet, that should not go outside of the room or outside of the biological safety cabinet. So it's to protect the environment also. So this is a schematic diagram of biological safety cabinet airflow. So if you see this A is a blower, okay, which blows the air, and this dotted line represents the contaminated air. So it is going upside, and then there is a HEPA filter here, and then this contaminated air then gets sterilized, and this is your workplace. So this whole workplace is now ready to work with the sterile things. And then here this is from outside of the environment, the contaminated air is coming down and the blower is sucking it up and then again recirculating it. So this whole area is safe to work, and it's like aseptic condition to work with your cell culture or any bacterial culture. So in class 2 labor biological safety cabinets, equipment is laid out to not restrict the airflow in the cabinet. So if you see in this figure, all of the stuff is like scattered. So that is making problem with the smooth airflow, smooth decontaminated airflow of the laminar flow unit. So its operation is what it operates. So it divided into two categories. Okay, class 2A1, class 2A2. So class 2A1, it's not designed for chemical use, may be used for non-volatile toxic chemicals or low-level radioactive materials. Class 2A2 may be used for minor amounts of volatile chemicals if canopy is connected. I will explain you what is the canopy later on. So it ensure its annual certification. So every year it needs to be certified using by calling the company who are the manufacturer of the biological safety cabinet. So place all the work material into cabinet before starting. So make sure you have gather all of your stuff what you gonna need, and you already kept inside the biological safety cabinet, so that you're not going to disturb the airflow again and again by standing down and sitting while working with in biological safety cabinet. So what are the cautions? The chemicals may damage the HEPA filter. So HEPA filter is very sensitive. So if you are working with some volatile container, volatile chemical, that is gonna surely damage your HEPA filter. And also, if you are working with volatile chemicals which are not retained by a HEPA filter, so if whatever the person is working, that is gonna get exposed to those HEPA volatile chemicals. So to work with the volatile chemicals, we have a fume hood. So use a fume hood. Don't use the biological safety cabinets. So even if you want to anyway use volatile chemicals, so use having the fans with spark proof biological safety cabinet, because usually in biological safety cabinet, as it is not manufactured to work with volatile chemicals, it don't have a fan which is not spark don't have a fan which is spark proof. Okay. So chemical use may result in a fire or explosion. Never use flammable. Open fire can also damage the HEPA filter. So what are the centrifuge hazards? So if you definitely you will be working on a centrifuge. Okay, so there are hazards. So that may be a mechanical failure or lab equipment failure or aerosol generation or a operator error. And I know most of you guys already saw the Hollywood movie Contagion, where one of the scientists who was working with the pathogen, he mistakenly broke down his test tube in while working with the centrifuge, and that again leads to the exposure, his exposure as well as community exposure to that pathogens. So be careful while handling with the centrifuges. So ultraviolet lamps in biological safety cabinets, they are it's needed. Okay, if they are installed, okay, they must be cleaned weekly to remove dirt and dust. Check periodically to ensure the appropriate intensity of UV light is being emitted. Turn off the UV light when the room is occupied to protect the eyes or skin. Because UV exposure, even for 5 seconds, it can burn the cornea and causes skin cancer too. So definitely don't use an open flame in biological safety cabinet. As this cabinet is already having a aseptic condition, there is no need to use open flames. You can see after using the open flame, this is devastating. Like all the whole biological safety cabinet is burned off. And this is another mistake. So after using the flame, so everything is means it's like a this is a propane gas valve. Okay, and you can see what gonna happen like that. So whenever you are working on a biohazard work area, okay, mark the work area with the warning sign on the left hand side and contact information, so that if anything gonna happen, that contact person should be get contacted in any case. So what is the laboratory hygiene? Okay, definitely do not eat in the laboratory, do not drink, do not smoke, do not apply any cosmetics including lip balm or even a body lotion, because body lotion it gets absorbed in our skin, and if the body lotion absorbs the chemical from the surroundings in the laboratory, it's gonna get absorbed inside your skin also. So don't handle the contact lenses. Don't store a food or drink in a laboratory refrigerators, and don't wear open-toed shoes. So hand washing, how to so wash the hand immediately after removing PPE. PPE is a personal protective equipment. Once you have finished your work, remove the PPE and then wash your hands. So this is a cartoon showing that how to wash your hands, and definitely use a soft soap, because if you use a hard soap, you need to wash your hands 3 or 4 times in a day, while working in the laboratory. And if you are using hard soap, that is not good for your hand at all. And if you don't have any soap available, use hand sanitizer, but wash with soap and water as soon as possible. So as I say, what is a personal protective equipment? Okay, it is a first line of defense, you can say. Is it a last line of defense? Okay, use proper PPE. So if anything you did a mistake, that's will not gonna harm if you are wearing a proper PPE. So you should have a goggles, then gloves, then lab coat, which should be covering till your wrist, and then shoes, and definitely use the pants, not the shorts, while working in the laboratory. And there are different types of the lab coats, which are like burn resistant, water resistant, liquid resistant. So which we got not gonna talk now. So what are the spills? Okay, spills response vary depending on. So just imagine if you drop something, so you should analyze what was the spill and what is the amount you have spilled it, and then where was the spill, what is the potential for release to the environment. Spill should be cleaned up immediately to ensure proper decontamination. All the spills are to be reported as soon as possible to the laboratory supervisor. This is a must. And it should also be reported to the safety office, because they can track, okay, what happening with you after the spill happened. Is there any changes, or is there any hazardous thing happening with you after the spill has been happened? So once you have a spill, okay, when cleaning up the surface, use 10% bleach solution or approved disinfect. So mix bleach solution fresh each time. So don't make a stock of 10% bleach solution and keep using it. No, make it fresh every time, and use a hand gloves while using the bleach solution. That bleach solution definitely harm your hands. So put your wipes or paper towel on top of the spill. Spray and allow it to stand for at least 10 minutes before wiping it up. Dispose all wipes in a biohazard containers. This is an important point. Decontaminate any materials used to clean up blood or mop, sponge, buckets, etc. PPE should be removed and disposed of in a biohazardous container also. So for decontamination, generally for disinfection rather than sterilization. So this is a disinfection, not a sterilization. It depends on the choice, what type of the material to be disinfected, what is the organic load, because according to it, the decontamination procedure gonna vary. Then what is the chemical characteristics of the spill? Then most common the decontaminants are chlorine compounds and alcohols. These are a broad range available commercially. So disinfection, what to use for what organism? Okay, so if you have a bacteria, suppose vegetative bacteria like E. coli, you can use 2% domestic bleach, 75% ethanol, quaternary ammonia, or 6% formulated hydrogen peroxide. So for mycobacteria and fungi, it's same like vegetative bacteria, but you cannot use quaternary ammonia. You can use a phenolic compound instead. But phenolic compounds are also hazardous, so be careful while cleaning the mycobacteria or fungi spill. So spore forming bacteria, definitely 75% ethanol, not going to do anything, not going to kill the spores. So use a 10% domestic bleach. So you can see the bleach percent has now increased. You can use glutaraldehyde, that's a most good in spore forming bacteria, formaldehyde, and 6% formulated hydrogen peroxide. In case of viruses, so in case of envelope viruses like HIV or herpes, use 2% domestic bleach, 75% ethanol is enough to kill, and then quaternary ammonia and 6% formulated hydrogen peroxide. For non-envelope hepatitis or adenovirus viruses, use 10% domestic bleach, 75% ethanol, not gonna kill hepatitis virus. So use 6% formulated hydrogen peroxide, glutaraldehyde, or paraformaldehyde. So biohazardous waste container should be labeled exactly the same way. So this should be in orange color with the biohazard symbol in black color, and it should be written infectious waste. So during transportation of the dangerous good, so packaging requirements, so primary and secondary container, dry ice, etc. should be used appropriately. And just be careful about what is the route of the transportation. Okay, either use the cart and go through a low traffic area. Don't take it in your hand, that might be fall off when you are working. And then there are regulatory requirements like classification, labeling, signing, documenting, which you need to do before packaging the dangerous goods. So this is a one of the flask, which is a discarding liquid flask, which I have taken the photo from one of the laboratories. This is below biosafety cabinet. So you can see there is no disinfectant present in the trap flask. Okay, flask not regularly emptied also. So you can see the whatever the stuff is there is, it's like bacteria or fungi, it started growing inside the flask. So there is no secondary container for the tap flask. So just imagine if you have an earthquake and this flask fall off, and if that is made up of glass, then it's going to spill all the contaminants to the floor. So what is the actual collection chamber? So this is you are working, and then you are sucking out the liquid. So this is a primary container, and then it's going to the secondary container, and then you have a HEPA filter or any hydrophobic filter, and then it's going to the vacuum. So but in flask B, you should have a disinfectant, which I already told 10% bleach. So if this is a 4 liter of flask, add 1 liter of the bleach before the work. Okay, and then so this 1 liter of 10% bleach will be able to kill any of the decontaminant for 4 liter of the 4 liter of the liquid. So this should be a ideal biosafety cabinet work area. So you can see the left hand side, this is a clean. You can see, okay, everything is nicely accessible. You can use it without wasting your time. But on the right hand side, it's totally stuffy. So this is particularly is getting eye catch. So this rear vent, you can see, I already show you how the laminar airflow works. So this is blocking the vent. So this stuff is blocking the backside vent. You can see clearly. Then store the supplies outside the biological safety cabinet. So here is the biological safety cabinet, and store the supply, but which is near to you, not much far. But you should have a normal waste container outside your biological safety cabinet. This is a black color. That means it is a normal waste container. You can put your plastic, which is not came in contact with any biological agents. And then you can see this is a correct. Okay, how gloves and gown should be worn. So you can see everything is this is incorrect. So this is open. So yeah, this person is exposed to the risk, but yeah, this person, the hand is totally covered. So this is a correct way to use hand gloves in collaboration with your lab coat. And definitely housekeeping, you need to have the desk clean. So this is so much messy and this is so much clean. But why this is important? So if there is any emergency happen, and if the biosafety officer came, he should be able to locate everything. So you can see the flammable sign, it's accessible directly, you can see, but here it's totally messed up. And then here there is a mistake. So these are the common mistakes I am showing you while we work in the laboratory. This should be avoided. So there is no soap available for near hand washing sink. And definitely don't use the sandals while working in the laboratory. No matter how fancy nail polish you are using, but cover it up with your shoes and use a base gloves, okay, so that the sharp container should not go inside. And gloves should not be worn outside the laboratory. Okay, use appropriate secondary container. If you want to transfer anything from the laboratory, one laboratory to the another laboratory, it should be leak-proof container, and it should be open and closed in the biological safety cabinets only. So make ready your container inside the biological safety cabinet, go in another laboratory, open inside the biological safety cabinet. And before transferring, disinfect the outside prior to the transport. And it should be, if you are transferring any biohazardous thing, just label it as a biohazard. So this is a very important slide. Actually, this most of the students have encountered the problem once they have a cell culture contamination. So firstly, you need to identify what is the source. Okay, what is the source means where the contamination is coming from. Okay, so the sources are actually when you request the cell line from either the ATCC or NCCS, you should make sure that that cell line is contamination free. Though the company says it's contamination free, but it's up to you. Do you want to take a risk, or you can check it, observe it, whether it is contaminated or no. And the second story is definitely the improper aseptic technique that gets improved once you practice the cell culture. So don't worry about it. So what are the types of contaminants? The first one is a microbial, which contains bacteria, mycoplasma, fungi, viruses, and another is a cellular. So cellular means cross contamination. One cell line may get contaminated with the other cell line. Then what are the signs? So the most common signs are turbid media, rapid decline in the pH, color change. So the media is usually red in color because of the phenol red. Once it is getting acidic, the media turns in yellow color. If it is getting basic, the media turns in purple or dark red color. What are the morphological changes? And if you are watching any filamentous structure, then definitely that is a fungal contamination. So how to take care of this one? So if you have any contamination, cross contamination, it's difficult to remove. But if you have any microbial contamination, the first, if you can do, just discard the culture, decontaminate the incubator, decontaminate the biological safety cabinet by wiping it with alcohol and keeping the UV light with 30 minutes on, and definitely decontaminate the incubator. So discard all the culture, whatever you have in the incubator.
5 minutes more, Nikhil, Dr.
Yes,
Nikhil.
yes, I will finish it. Thank you. What if you have a bacterial contamination? So usual concentration of penicillin is 100 units and streptomycin is 100 microgram per ml. But to remove the contamination, use a higher dosage. You can use a double dose. And for a fungi, treat with antifungal agents like amphotericin B, which should be used in 2.5 microgram per ml. In case of mycoplasma, how you cannot see it, but firstly do a PCR test. There is a kits available to detect the mycoplasma, and then treat with it the antimycotic agent. Most of the common antimycotic agent is a kanamycin, but there are the companies who are selling the kits. So yeah, this is the light side. So yeah, this was for the students. So can you recognize what is the problem they are making? So you can clearly see they are not wearing the full sleeve lab coat. Okay, the second one, their toes are open. They are not wearing the shoes. So this is, though this looks fancy, but this should be avoided. This may cause very means your exposure to the hazardous things in the laboratory. And yeah, that's it. Thank you. So hope you guys find it useful while useful guidelines to whenever you work in the laboratory and make.
Thank you so much for covering so important part of our work, and which is highly neglected and sometime. So thank you so much, Nikhil. Now
Thank
session is open for question. So through chat box, you can go for the questioning. And I'm again very much thankful to all of my speaker, Dr. Lean, Dr. Mukherjee, Dr. Nikhil Ghate, and people participated from across the world. Dr. Vicky from USC, Los Angeles, Miss Brinda Ghate, and other all our student participant and my fellow faculties all over the India who have joined. Thank you so much. And today we are concluding third round of our inaugural series. Thank you so much.
Yeah, thank you.